Hello again. Thank you for joining us. This is the Space Nuts podcast. My name is Andrew Dunkley, your host, and joining me, as always, is the great Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hello, Andrew. How are you doing? Are you well?
I am really well, believe it or not.
That's good.
Yeah, much recovered. Just took a bit longer than it would for most people because I'm just a sicko. But we've had a bit of a COVID development in Dubbo in the last day or so. We were notified late last night that a traveller had stopped in Dubbo, travelling from Melbourne to the Sunshine Coast in Queensland, and stayed the night in Dubbo and visited several places in town. And of course, they were later diagnosed as COVID positive. So now the whole city's on ready alert. Everybody's being urged to go and get tested if they've got symptoms and lock down or isolate. We haven't been locked down yet, but we're waiting to see where this goes. Hopefully nowhere. But we're on tender hooks at the moment. So fingers crossed this doesn't turn into anything. But yeah, it's a bit of a scare. But on the plus side, Fred, I think it'll wake a few people up, because I think we've been very complacent in this part of the world, in light of the fact that we haven't had a case in this region for a very long time, and people are just sort of sitting back and relaxing and drinking their pina coladas and thinking that what's the rest of the world worried about? Well,
now you know.
Here it is.
Yeah.
So. Fingers crossed. Now, you've had an interesting time because you went to Siding Spring Observatory and got snowed in.
Indeed, that's right. So we were officially snowed in last night on the mountaintop, Siding Spring Observatory, about 150 kilometres from where you are, and probably 700 metres higher up, I think. And you probably had a lot of rain last night.
Yep.
We got blizzards pretty well. We essentially were stuck on the mountaintop. It was fine because the plan was to be stuck on the mountaintop. We stayed at the Siding Spring Lodge, operated by the Australian National University. But this morning, when you and I were planning to have our Space Nuts podcast recording, we were advised that the road was clear, but it might not be clear for very long. So we hot-footed it out of Siding Spring and made the 6-hour journey down to Sydney, which is where I am now. And it rained all the way, Andrew, every bit of the way.
Yeah, we've had torrential rain, some of it sideways because we've had big, strong northerly winds blowing the rain in. The radio station leaked this morning because it was hitting the side of the building. So we found out where all the holes are, and that's the same place the mice have been getting in.
Oh, yeah.
It's been a pretty horrific couple of days, and we've had temperatures. I think we managed to get to 5 or 6 degrees today, and not much better yesterday. There's been snow in places you just don't ever see it. I mean, Coonabarabran up around the Siding Spring Observatory doesn't get it that often.
No, that's right. So it was 0 this morning at Siding Spring, 32 degrees Fahrenheit, and it looked, to my mind, it looked as though it was set to be snowy for a little while. And the last time I remember it doing this was, believe it or not, in 1984, when we were snowed in for a week, I think, if I remember rightly. And there were snow men and snow women appeared all over the mountaintop because that's the only thing to do.
Snow persons,
right.
as we called them when I worked for the ABC.
Indeed,
snow persons.
Right.
Yes.
That's what they were.
Yeah,
anyway,
well, as we speak, Fred, we're getting another torrential downpour. It is bucketing here at the moment. So, yeah, we've had well over 46 millimetres so far, but it doesn't sound like it wants to finish yet, and it was supposed to have gone a few hours ago, but it's still around. Anyway, we're going to get down to business because we've got a lot to talk about. On today's edition, episode 250, whatever it is, 256, I think, we're going to talk about Mavis. Now, you're probably wondering what Mavis is. Well, Mavis is a very popular Australian name, but it's also the name of a planned observatory that is going to be more powerful than Hubble, and it's an Australian creation. We're going to look at a dying supermassive black hole. It's not going to go out with a whimper, I don't think. We had a question from Sean in Charleston, coincidentally, because you'd already chosen to talk about this topic. He was asking questions about the Pentagon's release of pictures and videos of UFOs, which they've sighted around San Diego. So he wanted to know what we thought about that. Well, I have no clue, but we will talk about it. And we've got questions about radio galaxies and the North and South Pole and the Earth's rotation and the melting of the ice caps, what effect it might have. So we'll tackle all of that today. Okay, let's start. Fred, who is Mavis and why is she in the news?
Yeah, she's not, she's not a person. Normally Mavis is a who, but this is a what. And it's actually an instrument which is being built in Australia for the European Southern Observatory's Very Large Telescope, which is in Chile. And basically the instrument is going to, as you said, it's going to outperform the Hubble telescope on one of the four 8.2 meter telescopes of the European Southern Observatory's Very Large Telescope. That's its name, collective name for these four telescopes and a few other small ones besides. In fact, Mavis is destined for a telescope which is officially known as UT4, but all those four 8.2 meter telescopes of the European Southern Observatory have got names from Chilean indigenous culture, and UT4 is Yapun. And I can't remember which one that is. I think it may be Sirius. I think it's Sirius, the brightest star in our tradition. In Chilean, Yapun is probably. The other ones are named after things like the Southern Cross and other constellations. Anyway, enough of that, because that's not about Mavis. Mavis is actually an acronym. You might have guessed that, Andrew. And it stands for...
Shocker.
It's shock horror. It's first, the M is actually an acronym itself. The M is short for MCAO. And MCAO stands for Multi-Conjugate Adaptive Optics. So what that means is some very fancy technology that takes the twinkle out of stars, because the twinkle is a blurring effect. Astronomers hate it. And without the twinkle, you would always have performance equal to the Hubble telescope. So the twinkle remover, MCAO, is the M of Mavis. The rest is Assisted Visible Imager and Spectrograph. There you are, MCAO, Assisted Visible Imager and Spectrograph. And so what it does is what its name implies. It will allow you to form images of celestial objects with incredible clarity, because you're essentially eliminating the atmosphere, even though you're in a telescope on Earth. It's about 12,000 feet, I think, rather more than 3,500 meters, I think, is the height of the VLT, thereabouts. And that gets you some of the way, but the adaptive optics system is what really eliminates the blurring effect of the atmosphere. And so it will form images that rival Hubble. And in fact, essentially, it's expected to be 3 times clearer than Hubble. Sometimes these things take a while to get to. But the other side of it, the spectrograph, that's the really important bit, because spectrograph is that universal tool that astronomers use to probe what stars are made of, to probe what's going on in galaxies, to probe whether stars have planets around them. All of these things come out of observations with a spectrograph in which the light is broken up into its rainbow colours, and we analyse that barcode of information that is superimposed on the rainbow spectrum. So it's fantastic stuff. It's a number of universities that are involved. The leader, actually, of the project, he's certainly one of the senior members, a chap called Richard McDermott, who I know well. He's at Macquarie University here in Sydney. Richard and I have in common that we were both educated in the same Scottish university. The University of St Andrews formed in 1413, and I was there a couple of years later, Andrew. That's what it feels like, anyway.
You beat me to it.
Yeah.
I'm sure it does. Well, do we know when this will be online?
I don't know, but it's what's happened is the Macquarie and other institutions, including the University of Sydney, and I think there's an Italian component, as well as the Australian National University. They have done a sort of feasibility study, which has been accepted by the the gurus at the European Southern Observatory, and they're now kicking off to build it. The expectation is about 7 years to build. And these things, they take a long time, Andrew. They're not quick to build. One of the things that I was doing up at Siding Spring Observatory was basically sorting out a lot of stuff in the laboratories that I used to use when I built instruments, and I took decades to do it. So that was in the days when I used to build fiber optic instruments for astronomy. So it's 7 years is a sort of typical time for a major facility instrument like this. But what a thing to look forward to. As Richard said, he said that the instrument will permit scientists to push into a new frontier of the furthest and faintest things we can see.
Wonderful, wonderful. And possibly answer some of the questions that have been posed for many, many years. And yeah, can't wait. But 7 years. All right. Well, I think we can handle that. Better than trying to wait for a message from interstellar space, isn't it?
Well, that's right, a telegram. Or
okay,
like that.
Moving. Yeah, that's right. We'll carry a pigeon, a space pigeon, of course. Now, moving along, a supermassive black hole is dying. How does a supermassive black hole die, and will it go out quietly? We hope.
No. So this is.
I kind of figured.
Yeah. We have in space what we call AGNs. An AGN is an active galactic nucleus. In other words, it's something that is detected usually with radio telescopes, and it's telling you that the supermassive black hole at the center of this galaxy is voraciously consuming its surroundings. So there's this accretion disk of material spinning around it, which is being refocused. Some of it goes inside the black hole, some is refocused by the magnetic fields of the black hole to form jets which point right angles to the accretion disk. We've discussed that many times. But the active ones are very strong in radio emissions. And AGNs have been observed, active galactic nuclei have been observed for many decades. They are the stock in trade of the radio astronomy fraternity. They were high on the list of targets when I was a young astronomer. And in fact, the most extreme form of active galactic nucleus is something called a quasar, which is an AGN that's kind of going gangbusters. However, what's happened here is that we've seen an active galactic nucleus that has shut down. It has actually already shut down. In other words, the hyper strong activity of the black hole has switched off, probably because it's run out of stars and gas and things to gobble up. The area around the black hole at the center of its galaxy is now devoid of the gas that it needs to keep it active. So the active galactic nucleus has switched off, but we can still see it because there is something that I've always been fond of these things. It's called a light echo. So what you're seeing is basically the ends of the jet of material that was squirted out of the black hole. You can't see the jet anymore, but you can see the sort of gigantic bubbles of gas at the end of the jet, which are still being illuminated by the light from the black hole itself, which is from the active galactic nucleus itself, which has taken a dogleg path to get to us. It's gone out from the black hole, it's illuminated this jet that's been squirted out above and below the black hole, and then that's reflected it to us. And what it's done is put a 3,000-year delay in the time that the light has taken to get from this galaxy. And that's exactly what we call a light echo. We see it in many phenomena. Sometimes a supernova will shine on a dust cloud nearby, and the dust cloud lights up years and sometimes decades after the supernova has exploded. But this is a very nice example of that happening in the case of an active galactic nucleus.
Yeah, I think we've touched on similar things before, where we talked about an event that happened, a long time ago, but because of gravitational lensing, you could watch it more than once.
Yes, or reflection.
I suppose this is similar in that it's been a delayed effect.
Yes, that's exactly right. It's the delay that makes it a light echo.
All right. So tell me, what is the future of this black hole? What's ultimately going to happen to it?
Well, the black hole will stay contented at the centre of this galaxy, whose name, by the way, is ARP 187. Halton Arp was an astronomer. I met him once years and years ago, who catalogued active galactic nuclei and galaxies, in fact, optical galaxies. But so the black hole will continue, but it's run out of steam in the sense that it's used up its fuel. Now, we think that is a process that is, it basically shuts down an active galactic nucleus, because once the fuel's gone in the vicinity of the black hole, there's nothing for it to consume, and there's nothing. It's actually the disk of spinning material going around the black hole that causes the energy to come out. If that's not there, then you don't see it, and you've got what might be called a quiescent black hole, one that is not actually radiating lots of energy.
So it'll just sit there like a blob and do nothing for a long, long time.
That's about the size of it, Andrew.
Yeah, that sounds like me. Okay.
No
All
comment
right.
there. No comment whatsoever.
I'm just paraphrasing my wife. You're listening to the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.